Once you have completed with level 2, we are going to move on to level 3, which is rotation with gears. Um, the example that this is based off of that you can see on last year's robot is last year we had the amp bar have a 1-to-1 gear ratio for our first competition. That motor did not have enough torque by itself to bring the amp bar up, so we are now what the solution to that was adding a reduction with using gears. Instead of using the Vex gearbox like we always do, we use gears to do this reduction because of the space that we had, and we didn't have a lot of weight. So to get started, we're going to create a new level for our training. We're going to make this one level 3. And we're going to create a new document. And we're going to make this one called rotation with gears. If I could spell rotation with the gears. So we're going to go to the front face, do a sketch on the front face. And this is going to, for this example, this is going to be a 5 by 5 inch of aluminum. Sure. And first, we're going to start off with our motor. Our motor is going to be located somewhere around here, and the motor hole is going to be 1.5 inches by 1.5 inches. And then this hole here is going to be 7/8. That's so that everything that needs to fit through the hole will fit through the hole. So you can do 7 divided by 8, and it actually do that math for you. The next thing we need to do is we need to do our a circular pattern. Instead of a linear pattern, it's a circular pattern. So you could do a line circle, dimension that circle to be 0.201 because that's a clearance hole for 1032 bolt, and that's the same bolt that gets mounted for our motors. And we're going to dimension that one to be 1 inch because whenever we have this pattern, it's always going to have a 1 inch spacing for the motors to mount with. And with a Falcon in particular, it has 11 slots, but the pattern's actually for 12 slots. So we can do underneath linear pattern, if you click down that drop down arrow, you do circular pattern. You can click on that circle, and you got to drag this point to your center point of the circle, which is there. Now, like I said before, with the Falcon, it has a 12 hole spacing circular pattern, but only 11 are available. But we can just have all 12 because what's the extra hole going to do? So we change that number to 12, and now that should have 12 holes that we can use. Hit the little check mark, and that's done. So now oops, we have the plate, we have our motor hole, and the spacing for the motor if we're using a Falcon or a Sim motor or a Kraken. Keep this part open, and now what we have to do is we have to figure out how to figure out our spacing. Our standard spacing will be gears that adds up to 64. And the only gear that we have for motors is a 14-tooth gear. So to find out what the spacing is going to be, we can go to a website called West Coast Products. WC Products is the .coms is the way to get to this website. Go to resources, and we're going to do a gear calculator. We're going to work in the 20 DP, and gear number 1, which is our motor gear, it's going to be 14 tooth, and then gear number 2 for this example will be a 50 tooth gear. Because 50 plus 14 equals 64, we're going to have that combination almost 100%. The exact center, this is going to be the tolerance so that the gears aren't destroying themselves all the time. We're going to keep that at 0.003. So that means that we have the center distance of 0.106. So we can take this number here, copy it. And the cool thing is if we draw another circle and we dimension this circle to be 1.6 times 2, anywhere that we draw another circle um, along here, if we put that center hole for our other gear, it will mate with it. So we can play around with that. For this example, we're going to have this hole be 2.5 inches from the bottom of this base plate. So we're going to draw a circle. Make sure you're clicking on it. And we're going to dimension this center of it to be 2.5 inches from it. And this hole is going to be 1 1/8. 1 1/8 is 1.125. That's the standard hole for a bearing. So 1.125. And when we do this, we notice that this hole here is interfering with it. So whenever we do our extrude, we're just not going to include that one because this is not needed. We don't need to screw in all 11 screws into the Kraken. With We can screw in as many as available. And yeah, now we can do our extrude. We're going to extrude this out, and we got to make sure to extrude everything that we want included. And we want to extrude that hole too. And thickness is going to be 0.25. Let's do 0.125 for this one. So now we have a thickness of 1/8 and hit the check mark. So our plate is now done. So if we go to our assembly, like how we did before, we can go to our assembly and we can import that plate. So we do insert, you're going to see this plate here. And actually, let's go back and let's rename this one here as the gearbox plate. And now we can insert that plate into here. Now we have that part. So we can look ahead. We have the motor stuff, but we're missing out on our hex shaft. So let's actually make a hex shaft. So we can do an insert, create new part, and now we're going to make our hex shaft. We're going to do top view, sketch on the top view, and there should be a polygon option. Click on the center, and I like to click with the cursor on that line. And then now you gotta like go in like a circle to figure out how many um, edges that you want. For our hex shafts, we want 6 edges or yeah, 6 sides on it. Now we got to do a dimension, and the dimension is going to be zero point 0.5 because we have half-inch hex shafts. You hit the little check mark, and now what we can do is we can extrude that, and we're going to make this one 8 inches. This is just a random number. Again, when you get in part or in real life, you would know what number you want to work with here. So now we have our hex shaft. Let's actually rename it to be hex shaft. And now we can start inserting the rest of our parts. So parts we need, we're going to need our, our, we're going to need a bearing. So we're going to need the 0.5 bearing for a hex shaft. We're going to need our motor. And for this example, we're going to use a Kraken. We're also going to need our gears. So if we go to standard parts gears, if you click on this gear tab, what this link allows us to do is click on it and it's going to show multiple ones at the same time. You can look, well, this tab doesn't have it. Somebody can add that in later on. We can grab a 14 tooth 3/8. It's still, we know we have a 14 tooth gear for a Kraken and it's close enough for what we were working with right now. And then the other size that we need, like how we said in the calculator, is a 50 tooth. So we got to find our 50 tooth, and we're looking for the half-inch. It's going to be 52 3/8, which is for the smaller hex shaft, and 52 half-inch. We're looking for the half-inch one for this example. And you do the little check mark, and now it's time for us to start doing our mates again. So let's mate our bearing to be in there. That's going to be a circle mate, and then we're going to get the edge of this one here to probably be on the other side. So face to that face, flip the primary axis, and that might throw a fault. That's going to throw a hissy fit. That one's going to throw a hissy fit. And then we're going to do a mate circle. So now our bearing's set in the right spot. So now the next thing, let's mate our motor into the right spot. And that flange is not, no, because that's a circle mate. That's why it's complaining. let's delete that one too. Redoing this, so mate, click the two faces, do a circle mate, and then now we're gonna get the flange, this lip here, like how you would do it in real life, and you're gonna get that up against there. We use a planer mate, and now that bearing is fixed. So next, let's get the motor fixed in this location. Let's do a circle mate again. Let's grab it to here, circle mate, and now we're gonna drag the motor out of the location. We're gonna do a planer mate, and now we can see the motor holes here. And let's just do one of them to be a circle mate. So now when we do that, that motor's fixed. Let's also add the hex. Let's add the gear to the motor. So we're gonna do another circle mate. And with the look for anything that has a circle on it, not these sides, but like the circles in the center. Click on that to that circle mate. And now that is actually inside. And now we can grab this edge here, and it's actually made it to the Kraken, and we're going to do a planar mate here. So now that motor is only going to rotate. If you fix this, it's only going to rotate about the axis of the Kraken. And we actually forgot to insert our hex shaft. So we go to our current document tab. If we go to current document tab, it's be anything that's in here, and let's insert our hex shaft. Hex shafts are a little bit finicky when mating. What I like to do first is grab this face here to that face and do a parallel mate first. And now that we have a parallel mate, we got to do two faces. You can't do the faces that are parallel from each other because it makes no difference when you do it that way. So we're going to do a planar, click here, here, and that's one face. And now we got to get one that's not parallel, there, and then there. And that's our other face. And then we could do one more mate because there's typically going to be a collar here, and I don't have the collar inside the library yet, so we're not going to add that today. Um, we're going to do a mate from here to that face, and we're going to do an offset, and we're going to say 1 inch, 1 inch away. So now, nope, that didn't take it. Edit. I want to get, actually just delete that mate. Mate, planar, we need an offset 1 inch, and now that's going to have an offset of 1 inch from there. And with the shafts with the screws in there, because if we look at this here, we're gonna have clearance issues. We actually can't put a collar there. There's the Thunder Hex shafts where you put the hole in the center and you had the threaded screw. So that's how we would do it. That's how we actually did it during the season. But for this example, this is just proving the concept of how to use gears and find the distance. And now the last thing I do is mate the gear. So what we can do is we do a circle mate to this circle mate and circle mate. And we're gonna fix this. Apparently, it didn't get fixed. And now the last thing we're gonna do is we're gonna mate. The last things we're gonna do is we're gonna mate this to that face. It's gonna be a planar mate, and that's gonna fix that location. Nope, that broke it. Apparently, I'm gonna actually get rid of that circle mate. Mate that face to that face. This gonna be a planar mate. Yes. And then we're gonna do this top face to the other top face and do a planar mate. Yes, and no errors means it's good. And then we're going to do here So the bearing, so it's riding right up against the bearing, do a planar mate, and now this is done. Um, I challenge you to play around with this, but let's have this have more torque. Let's say in an imaginary world that we have access to a different gear um, for the 52th. If you can figure out how to give us, we're at a 3.5 to 1 ratio. If you can figure out how to get us to a 4 to 1 ratio and change the gearing and change the spacing, that is your challenge to make your rotation with gear by yourself.